In this video, we will look into several formats and standards that were developed for computational lexicons. Although most of the relevant dictionary productions of the recent past have relied on digital data and methods, there is little consensus on formats and standards. A great number of divergent formats have coexisted. Multilex and Genelex, generic lexicon, are systems that are associated with the Expert Advisory Group on Language Engineering Standards, EAGLES. Other formats used in digital dictionary projects are OLIF, Open Lexicon Interchange Format, MILE, Multilingual ISLE Lexical Entry, LIFT, Lexicon Interchange Format, OWL, Web Ontology Language, and DICT, Dictionary Server Protocol, the latter being an important dictionary delivery format. Unfortunately, currently available lexicographic resources consist of mostly isolated, incompatible data that needs to be linked, integrated, and enriched on different levels. A scalable, multilingual, and multifunctional language resources are needed with links between different elements of dictionary entries, lemmas or headworks, senses, definitions, multi-word expressions, etymology, etc., enabling any dictionary element to be linked with all other dictionary elements. Another standard considered was ISO Standard 1951, Presentation, Representation of Entries in Dictionaries, Requirements, Recommendations, and Information. Although this standard focuses on encoding the presentation of lexicographical data in dictionaries for human use in what is called LexML, lexicographical markup language, it deals with monolingual and multilingual general and specialized dictionaries. It specifies a formal generic structure independent of publishing media and proposes a means to present entries in printed and electronic dictionaries in a digitalized way, including dictionary compiling, editing, publishing, and distributing. The objective of this standard is to facilitate the production, merging, comparison, extraction, exchange, dissemination, and retrieval of lexicographic data in dictionaries. This processing model gives consideration both to the methodical formal structure that is required for the automation of dictionary making and its convenience for use. It takes into account the conventional stylistic layout and methods of the dictionary, which can be applied to both electronic or internet dictionaries and printed dictionaries. The international standard has the following main features. First, uniform framework and data items for microstructure. No matter what type of dictionary, work can be done on the basis of the same three structures. The differences between large and small dictionaries, multilingual and monolingual dictionaries, or general and specialized dictionaries lie in the types and numbers of data items. Secondly, separation of the compiling format from the display format. The format for the lexical data input is different from that for display. Compilers have to input information according to the tree structure. All the punctuation marks and structure marks can be automatically generating during the phase of data display and will be displayed on the preview interface. Thirdly, clear marking of the relations among microstructure information items. In the input process, imported data will be automatically tagged and checked when they are accessed or put in use. In this way, all sorts of data can be retrieved according to the compiler's needs, which contributes to a smart search. Fourth, standardization of formats for all the information or data. The database is built in the LexML format, and the lexicographic data may be exported according to specific needs and be connected to the interface of special typesetting systems, or be applied to other language processing, language database, or machine translation system. Fifth, flexibility in data retrieval and display. The LexML format is a universal model, and the data structure of subsets can meet specific needs as long as they are constructed according to the international standards of the XML format. And finally, sixth, good compatibility with current XML tools. XML has become an industrial standard, and naturally, the XML-based XML can be put into use as XML models are, and can even be edited with XML editors and XSL style sheets. It seems that after a few years of its existence, only few publishing houses have been using this format for their dictionary production line, unfortunately. Last but not least, when looking for an encoding standard for machine-readable dictionaries, this standard, called LMF, Language Resource Management Lexical Markup Framework, the ISO standard for natural language processing in machine-readable dictionaries, must be considered. It describes the lexical markup framework, a meta-model for representing data in lexical databases used with monolingual and multilingual computer applications. It is currently under review and will be replaced by a new ISO standard. LMF provides mechanisms that allow the development and integration of a variety of electronic lexical resource types. There have been discussions, described by Romery in 2010, about the possibility of creating a TEI serialization of LMF. In modeling lexicographic data, it has become common practice to conceptualize the underlying structures as tree-like constructs, which makes XML an ideal syntax for expressing the data. Another option from software engineering is UML, Unified Modeling Language, which in turn can easily be serialized into an XML vocabulary. This approach was taken by the authors of LMF. The automation of language information processing requires the formalization of language description, which means encoding natural language and computer information in a specially designed encoded meta-language. The most commonly used encoding languages or markup languages for electronic files are Standard Generalized Markup Language, SGML, Hypertext Markup Language, HTML, Extensible Markup Language, XML, and Document Type Definition, DTD. The grammar modules used for formal representation of languages are Generalized Phrase Structure Grammar, GPSG, Lexical Functional Grammar, LFG, Head-Driven Phrase Structure Grammar, HDPSG, Categorical Grammar, etc. In addition, many linguistic theories can support computational lexicography, such as logical and mathematical semantics, conceptual dependency, case grammar, word grammar, Montague semantics, meaning text theory, frame semantics, and so on. These theories are widely used and studied by lexicographers. Modern lexicography content is created with help of dictionary writing tools, corpus query systems, and QA applications, and become more easily accessible and useful for integration with numerous language technology solutions as part of bigger knowledge systems and collaborative intelligence. At the same time, extensive interlinked language resources, primarily intended for use in human language technology, are being created through projects, movements, and initiatives such as linguistic linked open data, meeting requirements for optimal use in human language technology, e.g., unique identification and use of web standards, RDF or JSON, leading to better federation, interoperability, and flexible representation. In this context, lexicography constitutes a natural part of the LLOD scheme, currently represented by WordNets, FrameNets, and HLT-oriented lexicons, ontologies, and lexical databases. However, despite attempts to embed lexicography in a theoretical framework, a new research paradigm and common standards are still lacking, and so are common standards for its interoperability with HLT applications and systems. In 2016, GlobalX was initiated, a joint proposal by 5 continental lexicographic associations: the African Association for Lexicography, Asian, Australasian, the Dictionary Society of North America, and the European Association for Lexicography, supported by the International Conference on Electronic Lexicography, ELEX, Electronic Lexicography in the 21st Century. GlobalX aims to explore the development of global standards for the evaluation of lexicographic resources and their incorporation with new language technology services and other devices. Given the practice of lexicographic data reuse so far, as well as the shared interest in current issues, one would expect to see communication and collaboration between lexicographers and representatives of other disciplines, in particular natural language processing researchers. Remarkably, this is hardly the case. Current lexicographic resources, both modern and historical, have different levels of structuring and are not equally suitable for application in natural language processing. European language infrastructures are currently working on lexical description of individual languages in national language institutes. A recent attempt to improve the present situation by creating European lexicographic infrastructure, e-lexis, aims to develop strategies, tools, and standards for extracting, structuring, and linking lexicographic resources to unlock their full potential. e-lexis aims to integrate, extend, and harmonize national and regional efforts in the field of lexicography, creating an infrastructure that will enable efficient access to high-quality lexical data in the digital age, and bridge the gap between more advanced and lesser resourced scholarly communities working on lexicographic resources.